Hello everyone. Today we are going to discuss about algorithm analysis. Let's get into the topic. For analyzing algorithm, it follows some 6 steps. So we'll see one by one. So it starts with understand the problem, decide on computational means, exact versus your approximate solving algorithm design techniques. Then the third step is design an algorithm. Next is prove correctness, analyze the algorithm, then code the algorithm. So these are all the process, or we say these are all the steps we carry out when we analyze an algorithm. This is the first step of your analysis, algorithm analysis process. Understand the problem. So first of all, we must understand the problem thoroughly, which means we have to read the problem description carefully to understand the problem. Then only we can give the solution. So the next is we must ask questions for clarifying doubts, and the next thing is identify the problem types, what type of problem it belongs to, and if at all we have existing algorithm, we can just use that algorithm to solve the problem. And next is we should also freeze the inputs, what type of inputs we are going to give to the problem. So the next step is decision making. The first one is understanding the problems. Once we have reached what type of input we are going to give to the problem, all those things. The next step is the decision making. So it is like it has three things. One is we must ascertain the capabilities of the computational device. So what type of device we are going to use. And next is choosing between exact and appropriate problem solving. So whether I am going to have the exact output or else an approximate output. Like an algorithm used to solve the problem exactly sometimes and it produces correct results. It is called an exact algorithm. Or else sometimes if the problem is so complex, what happens? We cannot able to get the exact solution. So in that case, we can use approximation algorithm. So we should choose between these two things: exact, whether I am going to exact algorithm problem solving, or else approximate algorithm problem solving. It is based on the complexity of the problem we can choose. And the next is algorithm design techniques. So what type of design technique I am going to use, what type of approach I am going to use for my problem to solve the problem. Okay, so these are all steps involved in your second step, that is decision making. So on the third step is methods of specifying an algorithm. So in the first step, we have to understand the problem statement thoroughly, and the second is like choosing the correct algorithm approach, and the third thing is methods of specifying an algorithm. So I'm going to, after freezing everything, understanding the problem statement, I'm going to write an algorithm, right? So for that, I can use three types of I can write using in these three ways. So one is using natural language. I can like return statements, or else I can use pseudocode, or else I can go with flowchart. So these are all the three ways we can specify an algorithm. And the fourth step is proving an algorithm's correctness. So once I understand the problem, then I am choosing which algorithm I am going to apply for my problem to solve the solution. I must prove that algorithm's accuracy or the correctness. So that is based on, so once an algorithm has been specified, then its correctness must be proved. How accurate it is, that I must prove first. And the next is an algorithm must yield a required result for every legitimate input in a finite amount of time. So that is also very much important. Okay. So in an given particular time, finite amount of time, it must yield a correct result. And the error produced by the algorithm should not exceed a predefined limit. So this also we should concentrate. So three things: one is the correctness and the result, and the third one is the error. So these three things we must concentrate when we talk about this algorithm's correctness.